Okay, so in Math 7 today, we are starting section 4 for chapter 7. And we're talking about relations and functions. So we need to define these things and understand how to use them. So a relation is, when you talk about a relationship, what does that mean? A relationship. Nico.
Someone that's like close to you.
You just have some connection. He said someone that's close to you. So you have some connection. That's all. Okay? So that's exactly true with relations in math. There's some connection between things. Okay? So the definition is pairing of numbers. If I pair x's and y's together, I can graph them. They're little points. Okay? That's what a relation is. So today they announced the winners of the our local science fair thing for 8th grade. Next year you guys will be doing science fair. And you may end up collecting data the way that the students did if you looked out in the hall. They've collected a bunch of data. And that's just getting pairs of numbers in many cases. Okay? So if I wanted to, I could gather information here in this class. I could say, I want to know at what age you're what height, right? Raise your hand if you are 12. Okay, look at that. A lot of people in this classroom are 12. About 20 people are raising their hand. And now, keep it up if you are all the same height. All the hands are down because they're not all the same height. Okay, so here's an example. I could say, look at, here's a survey of 4 people from the class. Is anyone 11? Raise your hand if you're 11. And there's a couple. Ooh, perfect. Okay, and raise your hand if you're 13, which is commonly true for 7th grade. So the other half of the class is 13. Okay, so we're looking at 4 students in this table who are either 11 or 12, right? And this is their height in inches. Notice they're not the same height. They're different. Could it be possible that I would find 2 students of the same height? Yes, it's possible. I just need to increase my survey, right? Get more data, which you'll learn in science. That's really important for finding the truth out of things. Getting enough data that you can be sure it wasn't just an accident that you got the results you got. Okay? So we could label the age x values and the height y values. We could do it the other way as well. But labels are important, so we know what we're talking about, right? The inputs, in this case, are the age, x, and we use another word to describe all of the inputs. So I think we've already used this word quite a bit when we were graphing in chapter 6. What do we call the whole group of inputs, the whole group of x's? And it begins with D. Who knows? All of the x's. Something. Jeremy?
Domain.
Good job, domain. Okay? And so, let's do it this way. Domain. And so all of the y values that we have in a given table, if you put them all in one set together, you call that set begins with R. What is it? I always say home on the range. Okay, range. So the way I like to remember it is X comes before Y in the alphabet, right? And D comes before R, right? So in most of our just basic math problems, X's are the independent variable or the domain. Y's are the dependent variable, the range. It depends on what X you put in. You get out the Y. So the Y is dependent, okay? So this is just a relation. It's just a set of ordered pairs, and I think we've already, let's go ahead and write the definition for domain and range while we're here. Okay, so pause the video and take that down. Okay, so relations are groups of ordered pairs. They have some connection, and that's all. Okay? Functions are more specific. So functions are relations, but not every relation is a function. So imagine function, if a watch is a function, well, let's say it this way. If a watch is not functioning, what would you expect?
Not working.
It's not working. Something is not right. Okay? If I am a teacher here at St. John's and I'm a dysfunctional teacher, not functional teacher, dysfunctional teacher, and you walk in the door of my room, what do you expect? Dysfunction. What do you expect? What does that mean? Dysfunction, not function. Or on the other side, if I'm a teacher and it's functional, what's happening in my class, what would you expect? Brandon? Huh? Teaching. Okay, so he says if I'm functional, it's teaching, but if it's dysfunctional, what would you expect? He's shrugging his shoulders, nothing. You don't know what to expect, right? You might have heard this word dysfunctional, like they might even use it to describe families. There's a functional family and there's a dysfunctional family. Can you think of any movies where there's a dysfunctional family? What movie? Cheaper by the dozen. Okay. Where the dad is striving so hard to get them to function, but it's chaos, right? It's chaos. And that's what makes it fun to watch, right? So a function in this case is you know what to expect. If it's a function, you know what to expect. Okay? So the definition is a relation where every input has exactly one output. Here's an example of a function. Y equals x plus 1. This is a function because if I put in 2 for x, if I put in 2, what do I get out? Put in 2, everybody, right here. If you put in 2, what do you get out? 3. Now what if I come back next year? Next year I come back and I put a 2 in for x, what will I get out? 3. This is not dysfunctional. This is a function. I know what I'm going to get out. Just tell me what to put in. I'll get the same thing out every time, right? So if it's not a function, I would put a 2 in next year and maybe get something else out, right? It doesn't follow a rule. See, things that are not functions can't follow a rule like this. This is a great rule and it's followed every time. X plus 1, okay? So we're now going to take down a series of relations. See all these relations? We're going to do it little by little. And we're going to state whether this relation, which is just a set of ordered pairs, is a function or isn't a function. So we got to take it down so you can see this. Make a little table of x and y. Pause the video and take it down, come back and we'll talk about it. Okay, so as we look at this, we have -1, 0, 1, 2, 1 for our domain. And in our range, we have 3, 4, 5, 6, 7, which is a lovely pattern, isn't it? It's a lovely pattern. So, thumbs up if you think this is a function. Thumbs down if you think it's not. Ooh, the thumbs are down. You're right, this is not a function. Why is this not a function, Jimmy?
Because the pattern is you got 4, but 1 plus 4 is not.
Okay, so he's trying to make a rule. He said the pattern is put in x and out, you would add 4 to it and you would get the next value. The other way to look at it is when we plugged in 1, we got out 5. But our definition says every input has exactly 1 output. When we plugged in 1 again, what did we get out the second time? 7. So if I plug in 1 again, what am I going to get out? 5? 7? 9? Oh, you just are so functional. If you say 9, you're just a very functional person. Okay, you're trying to create a rule, but we don't really know, do we, what we'll get out. So that's not a function. Okay? And take this one down, see what you think. Okay, so this is a bizarre looking thing. We've got all these different x inputs, and we keep getting 3, 3, 3, 3. So if I plug in 0, what do you think I'm going to get out?
3.
If I plug in -1, what do you think I'll get out?
3.
It seems like I'm always going to get out
3.
3. Is this a function? Thumbs up if you think it is. Thumbs down if you don't. And thumbs up if you think it is. I've only got 2 thumbs, 1 each direction. Oh, now I've got more up thumbs. And so you are right, this is a function. Isn't that a strange function? But if I plug in, look at, I plugged in 1 and I got out 3. I plugged in 1 and I got out 3. It's doing what it said it would do. It didn't what's that word? Conflict with what was there before, right? It was not contradictory. Okay, let's try it again. What about this one? Okay, so we're plugging in values. I don't see a value for the last one. We have negative 1, 0, 1, 2, 1, 3, 4, 5, 6, 5. Is this a function or is this not? What do you think? Thumbs up if you think this is a function. And anyone not think? Who doesn't think it's a function? And who wants to speak? Why do you think it is or isn't? Why do you think? Jeremy?
Because if you put in 1 there and there, you get out 5 more times. And when you put in 2, you get 6 and 0.
Well, we don't know what happens when you put 2, but do we have enough information to know that this is a function?
Yes.
Yes, this is a function. Okay, final one. Pause and come back. Okay, this one is kind of strange, like the second one was strange, right? But now every x is negative 1. Negative 1, negative 1, negative 1, negative 1. And then the y's are 1, 2, 3, 4, 5. So if I plug in the next negative 1, what would you expect?
6.
So is this a function? Thumbs up if you think it is. You got a couple thumbs. And who thinks it is not a function? Good job. It is not a function. I know it feels like a function. It is not. It feels so much like number 2, but it's different, isn't it?
Yep.
If I plug in negative 1, Jimena thinks I'm going to get out 6. Doesn't everyone think I'm going to get 6?
Yes.
It looks like such a beautiful pattern, but do we know that for a fact? No. So we cannot say that. You could also receive this information in little ordered pairs. So what might a person do to answer the question, is this a function? If you don't like ordered pairs, what could you do, Chad?
You could make a chart like we just did with the X and the X and Y and the Y.
Good. And then maybe some of you don't need to make a chart, but you could. You could say, okay, which ones are the X's? Can you tell me what are the X's, Chad?
1, 2, 3, 5, 7.
And then what are the Y's?
4, 7, 5, 5, 2.
So the question is this a function?
No.
Does anybody say yes? Who thinks this is a function? No one's raising their hand. Too bad, because it is a function.
Wow.
Isn't that bizarre? Why is this a function? Why is it? Okay, listen to Jonathan. Shh. Why, Jonathan? There was no repeating input, so do we know whether it would not be a function? We have not proven that it is not a function, therefore we'll say it is, which is very bizarre. I agree with you. Okay, you've seen almost every possible thing I can throw at you. It can be very confusing. Hopefully you're ironing this out. Number 2. You're going to say, 7th grade, you're going to say either function or not a function. 3, 2, 1. No. Good. Not. There's 2 ways to prove it here. It is definitely not a function. Okay? And you may begin.